Okay, so our elephant, did you guys try the elephant yesterday? You tried him already? All right, so we know that we've got gravity pointing downward, and then our elephant is going to have normal force that's perpendicular to the ramp, because we always have normal force perpendicular to the surface. And then there's some friction that's keeping him from sliding down. So when we draw our elephant, I'm going to redraw this as a force diagram. We've got gravity pointing downward. We've got gravity backward. I'm going to try to draw this nicely here. Gravity and normal force. Oh, this isn't gravity. Sorry. I misspoke there. That should be friction. And then we've got normal force that's pointing perpendicular to the ramp, because if we imagine our ramp as this blue line here, we can recopy that. It should be parallel to our force for friction, and then our normal force is going to be perpendicular to that. Because those are at a right angle, it would make sense if we put our axis sort of through that point. So we're going to go through the point. Normal force is going to be one axis, friction is going to be the other. And so if we're going to determine the components of a force, we're going to determine the components of a force that does not fall on those axes. And so the one we'll have to figure out is gravity. We're given an angle of 20 degrees here from the horizontal. And if we imagine that there's a horizontal line going through here, this triangle is drawn so that we've got a horizontal line, and then the slope that the elephant is on, and the angle between those is 20 degrees. So this is going to be where our 20 degrees lies. Which means that this angle is going to be 70 degrees. How do you guys feel about angles like this? Good, bad? So we can actually tell what the angle is between the pink line and gravity too. That one's actually going to be our 20-degree angle in there. So we can figure out some of these angles for these. But we have to be careful here, because I know that there's a tendency for us, once we see a triangle in our force diagram, to use that to try to solve problems. And we don't want to do that, because that would be the wrong triangle. What we need to do is draw our rectangle like we normally do, and then we can start to solve for it. So I'm going to use, I'm going to look at my line, my vertical line, the one that I drew is pink, and I'm going to draw a parallel line to it that has the force that I need to break into components as the diagonal of that box. So I'll draw that there. And then the other side is going to be parallel to my horizontal line like this. So we're going to draw, ultimately we're drawing a triangle that is congruent with this other bigger triangle, but this big triangle is really just telling us where the angles go. It's not telling us about the magnitude of those forces. I'm going to draw these arrows. Okay. So for numbers, we are told that our elephant has a mass of 2,000 kilograms. So how many newtons would that be? To figure it out, we're going to do our 2,000 kilograms times minus 10 meters per second squared. So that's going to have a force of minus 20,000 newtons. Okay, I'm going to redraw my triangle because this is tiny. So if I redraw my force diagram triangle, I'm going to have 20,000 newtons. I'm going to have 20-degree angle. All right, so now my right triangle is in here, which means this is my hypotenuse. My blue line is going to be my opposite angle, and my pink line is going to be my my opposite side and my adjacent side. You guys have any questions so far? Is that about what you did? Awesome. You guys are doing great. All right, so to solve for these, if I'm going to solve for the adjacent side first, if If I'm doing the adjacent side, I need to use cosine. So the cosine of 20 degrees is equal to my adjacent side. How did I draw this? So that was my vertical. So this is FGX, GY. Be FGX divided by minus 20,000. So FGX equals minus 20,000. And the minus here only means that it's pointing downwards. Calculator, 20,000 times cosine 20. I got 18,794 newtons. And so that's going to be the amount of force that's holding the elephant to the ramp. He's going to have a hard time jumping off the ramp. If I figure out the blue one, I'm just going to highlight this so we know which one it is. That's the pink one. The other one, I'm going to use the sine because I need the ratio with the opposite side. So the sine of 20 degrees is equal to FGY divided by minus 2,000. I actually didn't put minus in here. This should actually be minus. And then for the other one, minus 6,840 newtons. How'd you guys do? Okay. Anybody have any questions about it? About setting it up or doing the calculator part or math or anything like that? Are you guys as confident about this as you seem? Would you tell me if you weren't? You guys are so quiet. Okay. Tarzan problem. Oh, Tarzan. You guys ever worried about Tarzan when you watch Tarzan in a movie? There hasn't really been a Tarzan movie since you guys have been alive, is there? It's been a while. In the 90s, there was two. Okay, so we've got Tarzan. He's preparing to swing, and much to his dismay, his loincloth gets stuck on a branch. This is trouble, especially for Tarzan, who basically lives by himself in the jungle, right? He's left hanging with the vine pulling upward at a 40-degree angle, and his loincloth pulling him horizontally to the right. Draw a force diagram for Tarzan. Be sure to break angled forces into components and indicate which forces are equal with equality marks. All right, you guys ready for this? Here we go. First step, force diagram. So we're going to have a force first. We've got the vine for sure, right? We've got a vine going this way. Is it okay if we call that tension? You guys want to call it pull? It doesn't really matter, does it? We can call that tension. And then we've got a branch holding him by the loincloth here, right? So that's going to be kind of backwards like this. So I don't know, force, branch. It's probably just a pull. What else is he experiencing? Why does he need the vine at all? What would happen if he didn't have it? He'd fall to the ground, right? So we've got gravity in here too. Okay, so there's our forces. First thing we need to do is figure out which ones, let's see, draw a force diagram, be sure to break angled forces into components and indicate which force. Okay, so we're gonna do our axes first. So I'm gonna look at this and I'm gonna say, are there two of those that have a 90-degree angle to each other? And it looks like these two do. Oh, you just reminded me I didn't take attendance. What's up? How's it going? Good. You're fine. We're just working on some of the problems, and I'm filming them, so we'll be able to post them online and be able to see what's next. Oh, look at that. It's all marked as present. Oh, that's Mondays. I don't know why it does that. I told them, I was like, you need to make it so that it defaults to the current day. Okay. So back to Tarzan. So because Tarzan has this 90-degree angle happening here, it makes it pretty easy for us to set up our axes. So I'm going to go ahead and make them right here. So that's going to be my horizontal line. And I'm going to use the force due to gravity to make my vertical line. And then to break the angled forces into components, I've got this tension force with the vine. I can break that up. So my rectangle is going to be right there, which means my two forces are going to be this guy, call it FTX, and then I'm going to have FTY. Now this new part here, indicate which forces are equal with equality marks. If Tarzan is being held back by the branch so he can't swing on the vine, he's not accelerating anywhere, which means that we've got some forces that are going to be balanced with each other. And so they will be equal in magnitude but have opposite directions. And so we're going to have two of those sets in here. One set will be the vertical ones, which are the upward pull from the vine and the downward pull from gravity. Those should have equal magnitude. The other two that should have equal magnitude is this force forward from the vine and the fact that the branch is holding him back by the loincloth. I always feel bad for Tarzan in this problem. Do you guys have any questions about that idea? We've done similar things before just with setting up equality marks, but this is the first time we're going to do something with numbers with it. Next, it tells us write an equation for the vertical forces on Tarzan. Look at our equality mark. So what we can do, there's two different ways we can write these. I'm going to show you guys both of them. One is that we can say, okay, these are, what we're saying by putting these marks in here is that they're equal to each other. So we could say that, I'll do this in colors, that FTY is equal to minus FG. We can rewrite that equation by adding FG to both sides. So we could also write this as FTY plus FG equals 0. You guys see how those are both the same equation? It's just written two different ways. So if you prefer, you can write them like this, where you have forces on both sides and one side is negative. Or you can just add up all the forces on one side and make them all together equal to 0. It's the other way you can do it. Both of them are 100% correct because it's the same thing. For the other one, we've got this FTX. And we can say that's equal to minus FB, or we can say FTX plus FB equals 0. Either of those. Oh, sorry, this one just said vertical. Started off okay, then I lost it. Okay, so there are my vertical ones. These are my horizontal ones. Sorry about that. I put them in the wrong place. I feel bad. Next it says Tarzan's mass, 75 kilograms. Calculate his weight. We talked about that a little bit yesterday, is that the idea that weight is not the same thing as mass, but weight is force due to gravity. Some people also write it as FW. Either one is fine. Either way, the way that we can solve for that is that gravity is going to be equal to mass times acceleration due to gravity. So with a 75 kilogram mass, Tarzan's weight is going to be minus 750 newtons. The next two questions.
So Dr. take it?
Oh, yes, he did. I'm sorry about that.
Great thing.
Zane, I have to give you a seat on the seating chart, so I remember to put you in the attendance. Okay. So the next two questions. One says use the appropriate equation for forces on Tarzan to determine the tension in the vine, and then determine the tension in his loincloth. So it's asking us to solve for FT and FB, but the way that we're going to do that is by using what we know about FG. Because if we know FG and we know an angle, we can figure out, or we know FG, we know what FTY must be. If we know what FTY must be along with an equation, we can figure out the other two forces. So I'm gonna, let's see, how should we do this? Let's write minus 750 newtons there. We know that this one, FTY, has to be plus 750 newtons. So we know that much. We also know that if this angle is 40 degrees, that this angle down here must be 50 degrees.
Excuse me, would you send Sam Campolo down to the office for a minute?
Yeah, I can.
Thank you.
So if we know those angles and this side, we can figure out the other stuff. So to figure out the tension in the vine, we're going to use a triangle that looks like this. Where this side is 750. I'm going to go with this being 40 in here. And I want to solve for FT. Oh, 750 degrees. What am I doing? 750 newtons. This is my right angle. That means FT is the hypotenuse. And the 750 is the adjacent side. So with an adjacent side, we're going to use cosine. So the cosine of 40 is equal to 750 over FT. So FT is 750 divided by the cosine of 40. So I got 979 newtons for the tension in the vine. We know that the tension in the loincloth is coming from the horizontal forces. So now that we know FT, we know that that's 979. What we need to find is something that's going to be equal to that tension in the loincloth, which is going to be equal to the forward pull from the vine, which is going to be equal to this side of our triangle. So we could redraw the same triangle. Got 750 there. 979 at the hypotenuse. I've got an angle of 40 degrees. There's my right angle. And this guy is going to be equal to the branch on the loincloth. So to solve for that, I could either use tangent or I can use sine. I'm just going to use sine. I have like this hierarchy of what I choose. Sine is my preferred one. If I can't use sine, I'll use cosine. I'll only use tangent in like a last ditch effort if I don't have other information. Anyway, that's just my preferences. Sine 40 degrees is going to be equal to the opposite side divided by the 979 that I got before. So I still have that stored in my calculator. So I can use that to figure this out. Because the force from our branch is going to be equal to 979 newtons times the sine of 40 degrees. So since that's my most recent thing, that 979, I'm just going to multiply that times the sine of 40. And I got, for that force, 629 newtons. What questions do you guys have? Any questions? None at all? All right, so our task for the rest of the day then is going to be to take a look at the skier and work out things for the skier. So with our skier, keep in mind, let's see, I'll give you guys some tips because why not? So he's got, it says use a coordinate axis parallel and perpendicular to the hill surface as in questions 5 and 6. So our axis is going to be along the slope like this. And we're going to have a vertical line that goes through our skier. Like that. That's a nice thing to do because it gives us normal force going upward. Then from the slope, we've got gravity downward. And he's going to have friction just like every other problem on a slope so that we have a right angle in there. Where this is 35 degrees, it means the angle between the slope and the horizontal. Okay. Are you guys ready to try this? You're welcome to talk to each other and work together while you do that. And then you just need to finish drawing up the force diagram and then B, C, D, and E. And then we'll be done with that one. All right, guys, you can go ahead and get started.